Okay, so we want to draw a helix of 1 revolution upon a cone having a diameter of base 75 millimeters, height of 100, and a pitch of 75 millimeters. So we won't draw the end elevation. So that is what we are going to do in this exercise. Okay, so straight away we can draw this center line. And then we can draw the base of the cone. This is basically helping us to locate the center of the circle, which would be the base of the cone. So diameter was 75, so radius is 37.5. So with your compass, you can measure and draw that in. Then we can throw these projectors upwards onto the front elevation. Now that basically would be the flat part of the front view or the front elevation. Then we can measure 100 from the base. That will give us the apex. Now we want to locate Q, which is the pitch, and we measured 75 from the base of the triangle. Now we will divide the base into 8 equal parts. So you either use your set square, 45 degrees set square. You may use your protractor and use the circle division method. That's also fine. And then that's point Q and point Q. So we can label this. Note we are labeling in the anti-clockwise. Sorry, we are labeling in the clockwise manner. Now we'll divide the pitch, which is 75, by 8. And then we'll divide the pitch distance into 8 equal parts. And label them. So from Q to 1, 2, 3, 4, 5, 6, 7, and 8. Now we can project verticals from the plan to the front view. So 7 through 1, then we connect to the apex. Then 3 through 5 we connect to the apex, and then to get the helix on the front view, the intersection of vertical line 1 and horizontal line 1 will be P1, vertical line 2 and horizontal line 2 is P2, so on and so forth until we get to point 8. So you label the points. You realize I haven't labeled them in this exercise, but you label the points from P1 to P8. Now we want the plan view of the helix on the front view. So we draw vertical lines downwards. So from point 1, we draw a line until it intersects with the 1,5 divisional line, and that is the point 1 on the base. For point 2, we will project it to the directrix or to the side and then draw it downwards to the diameter or to the diametral line like that. And then using your compass, you stand at the center of the circle and open to where the vertical line from 2 got to, and project or draw an arc to the 2 line, and that will be how we get point 2. So for point 3, we just project it downwards to the 3 divisional line on the plan. Point 4, we project it to the 4 divisional line on the plan. So goes for point 5. Then for point 6, we have to use the same technique we use at point 2. So connect to your generator, then down to the diametral line, compass at the center of the circle, open to the intersection, and then draw an arc on the 6th line. So you stand at the center, open to that point, then draw an arc to intersect with the 6th line. That is point 6. Then point 7 is a simple vertical to the 7 divisional line. And then point 8 is also a simple divisional line, a simple vertical line from point 8 on the front view. So we label the points P1, P2, P3, P4, all the way to P8. And then, now with the help of our French curves, we can draw the helix. Let's begin with the front view. So from Q to P1, P2, P3, and P4. Now mind you, from P4 to P5, P6, P7, and P8, that should be represented with a hidden line, because that's a hidden detail from the front view of the helix. So you see I have those dashed lines. And then same French curve, we draw the projection of the helix on the you draw the projection of the helix. On the top view or on the plan. Okay, so that's just about it. Once you've drawn in or you connected the points on the plan, that is your solution.